welcome to day 22 of our 30-day coding challenge from CS and Math. And if you joined us yesterday, we looked at a three-step process for programming any formula in Python. And that was a very basic approach we used for, we used an example of converting from Celsius to Fahrenheit, although you could use it for any formula. Today I wanted to jump into a more complex formula like quadratics. And within that, we'll talk about if-else conditionals. We'll talk a lot about the logic in the structure of the formula. And at the end, we'll reverse factor using that process. So a lot of times people will say that quadratic formula really doesn't have a place. Well, as long as we're talking about algebra and stepping up from linear equations into something with curvature, it's always going to have a place there, and it's always going to at least be introduced. And the quadratic formula allows for partnering your knowledge with computing, which we'll show you today. So go ahead and get set up, and we'll jump in the coding from here. So we just Google search quadratic formula, went to images, and I'm sure most of you are familiar with this if you're in the world of math and science. So remember, this only works if your quadratic is in the form of ax squared plus bx plus c equals 0. If your polynomial is not in that format, right, the formula doesn't work. But essentially, we talk in math about looking at what's underneath the square root first to determine how many real solutions there will be. And we call that the discriminant. So I've already searched it to make things a little cleaner here. And I am sure people already know this, but just to cover it again, if the number under the square root is negative, that's where you end up with imaginary solutions, right? So if your discriminant is less than 0, you get imaginary solutions. If it's exactly equal to 0, that means in the formula the plus 0 and the minus 0 produce the same result, which is going to give you like a double solution at the same value. So there's still, in my head and in your head, probably two solutions. They're the same. So let's jump into what that might look like. So we're going to go ahead and use the same three-step process. I deleted out all the welcome code there, and I'm going to just paste in for you to make it faster the three inputs. So A gets the integer. Remember, we wrapped this input command in an integer because we're only going to do when the A, B, and C values are equal to integers or whole numbers. So for prompt for input, and you can put something where this formula only works for if the equation is set equal to 0, something like that. But obviously if I run this now, I'm going to just reframe this and say, well, if A equals 1, 5, 6, maybe I have some quadratic in mind, so I can hit this. Notice nothing happens, but there's no errors. We're entering in and it's prompting for those. So that's step 1. Step 2 we said is the calculate and store stage or step. And when we do this, again, we are going to start with this discriminant. And I don't want to type out the whole word, so I'm just going to call it D for discriminant. And we're going to say D is equal to B. To square, you do 2 multiplications, or to raise to a power, b squared minus 4 times a times c. And then again, this is a good place for kids to say, okay, can I check and make sure this is working? And just have some basic ones printed out. So we're just going to print that d value. Because sometimes, like, do I need parentheses? Are my order of operations working correctly? And students won't know, like, if they're doing that correctly. So let me pause and think of something really easy here. Okay, so there's multiple things you could do. As I was testing stuff out, I was like, sometimes it might just be easy to just be like, make them all like the same value, like 1 and 1 and 1. Say, okay, if I squared 1, I get 1. And if I take 4 times 1 times 1, I get 4. So 1 minus 4 should be negative 3. Okay, check, it's doing what I wanted it to. And again, this is just good verification in the process. So we have code here to get our discriminant. If there's ever any question, you're like, well, I want to make sure that that's being squared first. That's where you just use your parentheses like you would in normal order of operations. So sometimes parentheses can be good to add in. Notice here it would just work the same way. Oh, I guess I removed the print statement, but you get the idea. Okay, so that calculates just the discriminant. Now here's where we want to add our if-else logic. Like we just talked about in this image here, these are our three kind of scenarios. So really, if that d value is less than 0, that's where we want to say, essentially we're going to print out no real solutions, right? We would have imaginary solutions. And maybe we'll see how much times at the end. There's easily a way you could add like an I in there and make them come out if you wanted to include imaginary numbers. I wasn't really going to cover that today, but you certainly could. So if that condition is met, then print that out. Then I could say else, and in here I would say else I want to actually run the quadratic formula, right? So I have this situation where we shouldn't really run it, and then this situation where, yeah, we should run it. And when I say we shouldn't really run it, what I guess I should say is that if the discriminant's negative, it's going to, when we eventually put the formula in here, square rooting negative is going to produce, probably in Python the same way it would on a calculator, is going to produce an error, right? And this will help it bypass the error. I should also say that you want to use these if-else concepts when it's an either-or scenario. Either it is real or your answers are not real. There's really only two ways to get that. If this is met, it goes this way. If else, it goes this way. So those are scenarios where you know if-else statements can be helpful to you. Now, there's no plus or minus, at least that I know of in Python. I've never seen one or used it. I did look it up one time a long time ago, and I think there is not one. So we'll just separate these as two different formulas, although we'll just copy and paste. So the first x value, the first root, whatever you want to call these in your code, I'm just calling them x1 and x2. I would say I want to do negative b, right? Plus, we'll do the plus one here, sorry. Square root, SQRT is typically the shortcut for square root. Notice it's highlighting that, it doesn't like that. The square root of the discriminant, which we already did, right? The discriminant here is what we're square rooting, right? The square root of d, negative b, plus the square root of b, the discriminant, divided by 2 times a. Now, it doesn't like that square root. It says it's not defined. Did you mean something else? Well, I do happen to know that you're going to have to import that. It doesn't come, sorry, I should have put import, which we usually import our modules right away in our code. So import the math module. And now if you type math.sqrt, it's saying, okay, from that square root package that is now installed, pull that command out. So here, again, we want to think a lot about order of operations. And instead of testing this, because we're starting to get up here a little bit in time, you want to make sure that it's all over 2a. There's like a song, a Pop Goes the Weasel song, but we want to make sure all of this is over top of 2a. So this could, again, be a very good time to show kids, hey, you know what, if you want all this stuff on the top of the fraction and all this stuff on the bottom of the fraction, probably best just to use the parentheses right off the bat. So then we'll do the numerator first, then the denominator, then divide. Okay, and now once we have this one, we can just copy that and paste it, unless you're a really fast typer. And this will just be our second x value, so I'll just call it x2, negative b, and this is the plus or minus concept, right? So this one the first one has a plus, second one has a minus. And again, the fact that we coded this d out right away and assigned it is helpful because it saved our having to rewrite all that kind of clunky code here. All right, now again, here's where if you have a worksheet up or something, maybe I'll just pause and pull something up really quick. All right, so I just quickly went out here and typed in quadratic formula worksheet with answers. CUDA software is a very popular one for drill and kill type problems. If you're just working on raw skills, not reasoning. And so essentially, I have some examples. I know the answers. I can test them. So if I go in here, remember our third step is to display output. And I've already written this, so I'll just say print both x1. You can print multiple things at once, just separate them with a comma. And so now I'll test this first one. The first a value is 1, -5, -14. So I got 1, -5. Oops. Gotta hit the play button. So if I hit that play button, it's 1, -5, what was it, 14? And it looks like our solutions are good. Comes out to work. 1, -4, 4 for the second one. And it looks like, again, we have a double root there, but both of them are 2, so one single solution. And that's basically it. You know what I mean? We've got ourselves a functioning program. It works well. And I just want to throw one last thing in. Because the video is fairly long, I'll just do it, and then I'll just show it at the end. So to keep it short, like if I was going to factor this, or like you'd cover all that stuff with factoring. If you're going to factor this, it would factor into x minus set, or m minus 7, I guess would be m plus 2, right? So these are the values that you'd plug in to make it 0. So if you wanted to like reverse factor your quadratics, using this method, you certainly could just simply put in a statement like this. Now, using some logical reasoning, I could avoid, let's say, it printing out plus a negative. It's just really easy to write this code and not change much. Just default these to pluses. These to pluses here. But I just switched the actual root, like +7, to its opposite, and for both, and then inputted those in a string that will print out all of the factored form set. So think about it in this way: students could reverse factor all of their quadratics as long as the a value is 1. There's certainly things you could run into that would be problems, but no matter what, there's always a way to partner with the programming language and make it print out the answer for them. So this is a way to take something that's complex, take your knowledge of it, and make it work for you so that you don't have to do it by hand anymore. Hopefully you found it valuable, and leave your questions in the comments, and hit that like button, hit that subscribe button. We'll see you next time. Thanks.